The Unahuac Mayab University is the largest Catholic university in the southeast of Mexico. Founded in 1984, it belongs to the international network of Unahuac universities, which in turn form part of a whole educational system with campuses in 18 countries that serve over 100,000 students from preschool through postgraduate levels. More than 30,000 study at the university level in undergraduate and postgraduate programs, as well as extension courses. This network is comprised of 15 universities worldwide, with 10 institutions in Mexico, 1 in Chile, 1 in Spain, 2 in Italy, and 1 in the United States. In addition, virtual Unahuac University serves institutional corporate clients from 25 virtual campuses located in different countries throughout the world. The Unahuac Mayab University is conscious of its mission in society and has devoted much of its time and effort to the analysis of the environment, the detailed description of its most pressing needs, and has sought strategic alliances to be able to respond to those needs through innovation and the use of new technologies. A central issue in the global agenda, and specifically in the course of the last 10 years on the national agenda, has been the search for alternative energy sources, which are in harmony with nature and at the service of mankind, to attend to the development of the country and the world. The relationship between the Unahuac Mayab University and Recursos Renovables Alternativos constitutes a strategic alliance for the projection and development of research and technological innovation for the good of mankind.
Over the past 10 years, Recursos Renovables Alternativos have been studying and developing a process for the production of biodiesel from algae.
The first step of this process is a closed photobioreactor capable of achieving a very high volumetric productivity, providing at the same time the necessary reliability and stability to the cultivation process, and resulting in a very cost-effective culture system.
Since phototropic microorganisms are highly diverse in their morphology, one of our first concerns has been the knowledge of the physiology in mass culture. Nutritional factors are some of the important issues that we have taken consideration. The understanding of macronutrients like carbon, nitrogen, and phosphorus, the role that they play in cellular metabolic processes, the effect of the depletion of these elements, the role of essential trace mineral elements like iron that is very important in cellular biochemical composition, and its implication in fundamental processes such as photosynthesis has been our priority. The other major issue involved in mass cultivation of phototropic microalgae concerns effective use of strong light for photosynthetic productivity of cell mass and secondary metabolites. The knowledge of the light penetration depth as function of cell density, the effect of mixing cultures, the design of the mixing process inside the photobioreactor has also been a priority for us.
The effective use of light-dark cycle frequencies, the online monitoring of photosynthetic activity through the measuring of dissolved oxygen is just some of the other parameters that we have to evaluate for effectiveness of our process.
The third major issue, and also very important part of our technology, are the different mechanical designs that we have included in our photobioreactor. Example of this is the CO2 injection system, the design of the culture mixing processes, the fluid dynamics of the culture medium, the design of the gassing, the state-of-the-art process control system that monitors the nutrient consumption through the photobioreactor, the re-injection of the necessary macronutrients and trace minerals, the dewatering system, the online monitoring of the reinjected water, etc.
One of our most important capabilities is the use of one of our patented processes to lyse the algae. This process is mechanical and very cost-effective method that allow us to extract the lipids from the disrupted algae. The fourth major issue concerns state-of-the-art biodiesel production capabilities. The process that we have is a continuous process and is focused on high technology and the compliance of all the European regulations.
After years of scientific research and technological development, we have patented processes that enable us to grow and break algae in a continuous, efficient, and profitable way. The company's mission is to become the largest producer of biodiesel in the world, with a high profit margin and state-of-the-art technology. Renewable Resources will strive to become the preferred technology licensee and the global leader in the renewable energy market. Algae produces oil, and because of their growth rate and yields, they could produce a lot more than other energy crops. This oil is converted into fuels and medical-grade glycerin. From the rest of the biomass, the cellulosic part can be transformed into ethanol. Another part is high-value protein for human or animal consumption. When it comes to converting sunlight into biomass, algae is the most productive type of plant. Some strains of algae are as much as 40 to 50% oil by weight, leading to the hope of a large supply of oil that is much easier to convert into biodiesel than it is to ferment even corn into ethanol. We have achieved up to 50% of oil content with some of our productive strains. Microalgae specifically possesses several attractive characteristics in the context of energy and biofuels. First, they provide much higher yields of biomass and fuels, 10 to 100 times higher than comparable energy crops.
They can be grown under conditions that are unsuitable for conventional crops. Also, microalgae is capable to liberate oxygen, thus facilitating the reduction of increasing atmospheric CO2 levels, which is now considered a global problem. Algae biofuel is non-toxic, contains no sulfur, and is highly biodegradable. The reason to invest in biodiesel from algae oil with our technology
is because we produce third-generation biodiesel.
This biodiesel, which is B100, substitutes diesel from fossil oil 100% in combustion engines. All emissions are below the low calibration point of the grass chromatographer set by the Yucatan's Environmental Agency.
It's a last-generation state-of-the-art technology. It does not compete with the food chain. It only requires flat surface, sunlight, warm weather, and water. Water is 100% recycled.
Ours is a closed-circuit production process. Therefore, it does not become polluted nor pollutes the environment in any way. It is a sustainable process. Algae regenerates itself in every cycle. We produce no non-usable byproducts. Our byproducts are only high protein content biomass for animal and human food consumption, and glycerin at 99% purity for the cosmetic industry and other uses.
It complies with the strictest environmental norms of the European Community and those of the US regarding pollution and environmental policies.
It complies with Kyoto Protocol on Environment and Climate Change, which is a big issue nowadays. Its efficiency in land use is very high. Our system can produce almost 500,000 liters per hectare per year, as opposed to palm oil that produces almost 6,000 liters per year. As I mentioned before, the technology is 100% Mexican and is patented in Mexico and internationally. Generates high employment during construction and operation, and it can be replicated in any state or country, meeting the required needs of sunlight, warm weather, water, and flat surfaces. Besides the qualitative outstanding points, now is the time to invest in our technology because there is an excess demand for biofuels in world market. This allows for economic and financial projections to consider that the company will face a price and income inelastic demand for its products. Another reason is because the macroeconomic conditions in Europe remain weak, with a growing probability of a new recession in the next 12 months.
This will make biodiesel production a politically sensitive product and a priority for many nations, Spain and UK mainly,
especially if the production comes from corn or wheat seeds. And a third very important reason is because the US will still concentrate its biofuel production in ethanol. However, demand is in emerging markets for corn and wheat will keep seeds prices high.
This means that production cost for ethanol on second generation process will be higher compared with algae.